So we'll be starting it today. That will be the metal cutting. So it will be taking on this chapter will be providing basic backgrounds of different machining processes and highlights understanding important parameters that affect the metal and chip removals. So we'll be going through what is
This is
basically
okay.
metal cutting is
This is
and
okay.
what is the mechanism working behind this
कुछ
and
नहीं
the
खाना
parameters that
चाहिए
are being used for the
कुछ नहीं
machining
खाना चाहिए झूठ
and
बोल
that
रही है
every aspects that
ये
are being
पहले
used for
नहीं
understanding
रचे
सर उसको साउंड बंद
उसका
करवाइए ना,
parameters
बगल
for the
में बोल रहा है
machining
बच्चा।
for this purpose. Then metal cutting or machining is the process of producing workpiece by removing unwanted material from the block of metal in form of chips. So normally we see the metal is being taken off in the form of chips. The extra material or the material that is we can say used to shape the material to the desired shape, that is being the material is to be taken off from the workpiece and that is taken in the form of chips. The process is most important since almost all the products get their final shape and size by metal removal. So everything that any shape or size desired has to be taken off, and we'll be taking off the material of the workpiece, and that will be taking it in the form of chips. Either the material is taken off directly or indirectly, like in the form of other processes, like in the forging, extrusion. The material is not taking off, but it is being shaped also. So it depends upon the process to process on which, but everything the metal has to be taken off either directly or indirectly in this part. The major drawback of the process is the loss of material in form of chips. So everything that has been taken off is gone in the form of chips. So we'll be taking off these basic metal processes in this part. So what first one is the single point cutting tool. Removal of the metal from a workpiece by means of a cutting tool which is have a one major cutting edge. So single point cutting tool has a one major cutting edge in this case. So if this cylindrical turning on lathe, if we see this is the cutting edge of the tool in this case, this is tool, this is continuous speed, this is workpiece that is rotating in the form of and that is in the lathe machine. Then workable facing on the vertical boring machine. So if we see the vertical boring machine, this is the tool, this is the cutting edge of this. Here and this is the workpiece and this is the workable table or this is normally known as column. Then it is being rotating like this is rotating in this direction upon workpiece is rotating and the tool is stationary also in this part and it is taking out the metal by the single cutting edge or the major cutting edge in this case. Clear? So this is something like this explained upon this. So internal boring on a horizontal boring machine. So this is internal boring on a horizontal boring machine. This is tool. It is being rotated and this is what and this is the single point cutting tool and as it is rotating, the tool is also rotating in this moment. So this is the workpiece that is being taken off by the movement of the tool in this part. Clear? So this is again an example for the single point cutting tool. Then again the next example is that is the primary motion. This is machine service and shaper in this case. This is the planner for this purpose. The intermediate speed motion. This is the motion of the speed in this direction. Clear. So this is the workpiece. Clear. And this is the machine surface and the primary. This is the motion of this primary motion and this is intermediate motion. So this is the motion of this tool in this case. The workpiece is moving. The tool is stationary for this part and it is moving like in this direction. Intermediate motion or the speed motion of this is controlled by this part. So this is workpiece in this case. Then production of flat surface again in this case is this is the intermediate field and this is the primary motion in this case. So it will be going in this direction and the intermediate speed motion has been going in this part. Clear? So these are some of the examples of the single point cutting tool. The only characteristic for a single point cutting tool it will be having one major cutting edge. Clear? So if we talk of it will be having a one major cutting edge on this part. So let's move further. So removal of the metal from the workpiece by means of a cutting tool which have more than one major cutting edge. Clear? So now the next category is the multi-point cutting edge. So this and that tools that are having more than we can say one major cutting edge is basically your multi-point cutting tools. So this is the surface. This is rotating in this part. So as it is rotating, it is taking off material from this side. So this is how the slot is being cut. This is again the tool is being rotated and it is having. If we see it is having multiple cutting edges. So every cutting edge will be taking off the material from the we can say from the workpiece in this case. Earlier that we were discussing, it was having a single point cutting edge. So this was a single edge, this is a single edge, this is a single edge. Here again, this is having a single edge. Here it is a single edge that is cutting on this. But in the case of multi-point cutting tool, there are number of cutting edges. Here, so we have more than one major cutting edge in this case. So this is the surface plating. This is known as, normally we make a surface. This is our slot circuit. This is again the tool is having multiple edges. Then this blind or through drilling hole in this case. So when drilling hole in this case, so again if we see this will be going on, then again another edge will be going on, another edge will be going on. So it is basically, it is also an example for the multi-point cutting tool in this case. So this is broaching, this is broach and the workpiece. So when the broach is going down, it is taking with every edge, like one edge, second cutting edge, third cutting edge. So it will be every cutting edge will be taking off the material out of the workpiece in this case. Then again if we see here, so see here is a dovetail here. So dovetail, how it has been performed, it is with the shape of the, we can say, tool. In this case it is being rotated in the slot for this purpose. We will be giving our dovetail. Then it is form cutting. Form cutting also, it is rotation of the workpiece in this case, and this the tool is also having a multiple edges, cutting edges in this case. Then reaming, another is a process. Reaming is basically, we can say, finishing or enlarging an already existing hole that is being used. So this is process. Reaming taken as, this is a blind through upon this. This is a reaming that is enlarging an already existing hole in this case. So broaching on a vertical broaching machine. So this is, if we see, these are the, this is broach and this is the cutting edges of this. So these one edge, two edge, third edge, fourth edge, fifth edge. So every out of this, it will be, every broaching edge will be taking off the material by this. So this was some of the major examples. And if we say these are some of the, we can say, bifurcation between the single point and the multi-point cutting tool, and the edges and the mechanism from how they are taking off the material in this case. The chip is a material removed from the surface of the workpiece. Every material that is being taken off, or we can say chipped off from the workpiece, is in the form of chips. Principal parameters in the series are cutting speed V, clear, depth of cut W, clear, or we can mark it at D also, and feed is basically your F. Time required to turn a cylindrical surface into length LW is T is equal to LW upon Fn, where NW is your number of revolutions of the workpiece per second. There. So in the case of multi-point cutting edge, so time if we get to calculate, where L is of length of this material there, and again the FNW is your speed into number of revolutions of the workpiece per second, that is equal to time required to turn a cylindrical surface length. Clear? So rate of metal removal is N into F into W in this case, into where N is the number of revolutions into feed into W is your depth of cut, where rate of metal removal. So speed into feed into depth of cut, like in this case, this is surface speed and speed velocity, clear? So speed velocity is taken in this direction, and this is the distance moved in one revolution, feed thickness basically, that is typically 0.1 to 2 mm almost. So how the distance is being moved in one revolution in this case. In one revolution, how are you moving in this and taking out the material out of this. And this is the depth of the cut. How much the depth of the cut will be, like is it 25 mm? It is normally taken from, you can say, greater than 25 mm, not always constant, but it can vary also in this case. So again, if we see here, so this is the depth of cut W, clear, how the depth of cut is going on to this. This is the, how the depth of the depth will be taking off. This is the chip, and how much it will be going. This is the feed in this case. Clear. So if we see here, so this is your, we can say the angle for this. This is the rake angle and the clearance angle of the tool in this case. So how it, this is a tool, we can say angle that we'll be discussing just right now. So depth of cut in case of here is from here to here. If we see the enlarged image of this, this is the depth of cut W for this, and this is the chip that is being generated in this case. and how it is fed. This is in the A direction, and this is the feed upon this. So how the tool is fed upon this. So this is the feed. So this is basically the mechanism for the single point cutting tool. Here it's being taken in this such a direction. So again, out of this is your single point cutting tool. If we see, it has a major cutting edge upon this side. So this is, if we see, like here it was, what was we seeing upon this side? This is the rake and a clearance face of this. So this is the actual shape of the cutting edge. Where, so this is shank that is being holded in the tool holder. This is the axis of the tool and this is the base of the tool. The purpose of shank is, it is situated in the tool holder. It is used to hold the tool in this case. And you can see same all through the length. From here, we can see the angles are changed. The shape of the tool is same. Shank, it is the main body of the tool. Where, so it is normally used to hold, flank. The surface or the surfaces below and adjacent to the cutting edge is called flank of the tool. So basically, this is the flank of the tool. Clear? So the surface below and adjacent to the cutting edge. So this is below or adjacent to the cutting edge. This area is basically your major flank and minor flank. This is basically the adjacent to the cutting. This is the cutting edge. Clear? Major cutting edge. This is the touching to this is a major flank. The part away from this is a minor flank in this case. Again, the space on which the chip slides is called the face of the tool. Clear? So we can see here the face of the tool. This is on this chip gets to slide upon the face part. Clear? So this is your face of the tool. Clear? And then comes your heel. Heel is not shown in here. It is the intersection of the flank and base of the tool. Yes, so here is the flank and the base of the tool. Normally in this part it is known as your heel for this part. Clear? Then nose is this part. Clear? This, on this side, something like nose on this side. So this is the nose for this part. Clear? So it is the point where the side cutting edge and the end cutting edge is being taken for this part. Clear? So this is a point for the side cutting edge at the end cutting edge intersection. That is basically your the side cutting edge and the end edge cutting edge. So this part nearby is something like this. This is known as your nose for this. Clear? Then if we see primary cutting edge of the single point cutting tool, this is the feed. Here it can be like in this direction or this direction for this. This is the primary cutting edge. So it is the edge on the face of the tool which removes the material from the workpiece. So cutting edge, it is the edge on the face of the tool, clear, which is taking out the material from the workpiece. The total cutting edge consists of side cutting edge, that is major cutting edge, and end cutting edge, that is minor cutting edge. So the total edge is basically your major cutting edge and minor cutting edge. So this is the major cutting edge and minor cutting edge upon this part, that is normally known as major cutting edge, clear, and a minor cutting edge. So this part is normally we are talking of major cutting edge and minor cutting edge. It is, if we take total out of this, this is the major cutting edge of the tool in this part. Clear? Then a single point cutting tool may be either right or left hand cut depending upon the direction of feed. In a right cut tool, the side cutting edge is on the side of the thumb when the right hand is placed on the tool. So if we see left and right cutting tool, so the major difference between right and left cutting tool, so how can we differentiate in this? Clear? So in a right cut tool, the side of the cutting edge is on the side of the thumb. So if the side of the cutting edge is on the side of the thumb, clear? So this is primary cutting edge. If like this edge is facing the thumb, clear? So this is right cutting tool. If this edge is facing the thumb, like in thumb, that is known as your left cutting tool. And so it is very simple to see. If a right hand cut tool, the side of the cutting edge is getting on the right thumb, then it is your right cutting tool. And if it is on the and with the palm downward and the finger pointed towards the nose. Clear? So if we put a palm on the tool and we place our hand on the tool, the palm on the tool and the edge, or we can say the it is pointing the fingers are pointing the nose of the tool. So on the side to which the we can say that thumb is being applied, the primary cutting edge that has been designated as a left hand cutting tool or right hand cutting tool in this case. Where such a tool will cut when feed from right to left, as in lathe, in which the tool moves from tailstock to headstock. Clear? It's we can talk a left cut tool is one in which the side cutting edge is on the thumb side and which is on the left hand is applied. Such a tool will feed from left to right. So like if we see from the right hand cutting tool, it will be feeding from right to left, and the left hand wheel cutting tool will be feeding from left to right in this case. So that depends upon it is the left hand cutting tool or it is a right hand cutting tool in this case. The various type of surfaces and planes in the metal cutting plane are explained below, in which the basic turning process is shown. The three type of surfaces: the work surface from which the material is cut. Clear? So the number one, the number two, the machine surface. So principal planes and surfaces in this case. So this is cutting surface, this is machine surface, this is work surface. So this is the surface at the cut. This is x axis and y axis will be shown upon this axis. So this is the basic plane. This is the cutting plane. So this is the edge of the tool. Like if we see the shape of the tool, this is the flank of the tool. This is the face of the tool. So x axis is the cutting surface and the machine surface. So this is your cutting plane, and the basic plane is basically the on which the shank is placed. Flank is placed on this part. Then again on the other side is the cutting plane on the side of the cutting edge in this case. So the work surface from the material is cut. So this is the work surface from the material is cut. This is the work surface. Where from here we are cutting the material in this part. Clear? Then again it is a cutting surface or the machine surface. The machine surface which is formed or generated after removing the chip. So this is after the removing of the chip. This is the cutting surface that is being formed in this case. Clear? And then the third is the cutting surface which is formed by the side cutting edge of the tool. Then again is the cutting surface. This is the machine surface that is in the cutting edge that is striking the surface, that is the cutting surface, machine surface, and the work surface. So three surfaces are shown in this regard. Clear? So then again the references from which the two languages are specified are the cutting plane and the basic plane on the principal plane. So